Hi everyone, welcome to today's maths lesson. So building on the fluency that we looked at earlier in the week, we are timesing by 10. And yesterday we started to look at what actually happens to the digits in our numbers when we times by 10. So let's take a single digit number like the number 1. And when we times it by 10, the digit has to go into the next column because it's too big now for our ones column. So it has to move into our tens column. But we can't leave our ones column empty. So we have to put our placeholder there to stop our 1 from falling back into that ones column. And let's look at that with maybe like the number 3, for example. So we got the number 3, we times it by 10. Well, that digit moves into the tens column, and then we put our placeholder in that ones column. Super. So what we're going to do is we're going to have a quick look at what happens when we have a 2-digit number this time. So let's look at our number 10. So 10 is that's not the number 10. This is the number 10. There we go. So we've got 10. 10 is a 2-digit number. So if I were to times this number by 10, then what happens is both of the digits in these numbers have to move up to the next column. So our 110 now becomes 100. Our 010s now becomes, our 01s now becomes 010s. And then once again, that ones column is left empty. So I need to put a placeholder in there to stop my other digits from falling back into that ones column. So we started with 10. We times it by 10 by moving each of those digits up into the next column and adding our placeholder. So 10 times 10 equals now 100. Let's try that with the number 11. So if I times 11 by 10, then both of these digits have to move into their next column. So this 1 is going to move into the hundreds column, and this 1 is going to move into the tens column. Like this. But then that means that our ones column is empty. So I need to put a placeholder there, which is what we call our 0. So 11 times 10 would be 110. Let's try that with number 12. So 12 times 10. Well, each of my digits is getting 10 times bigger. So I need to move this 110 into our hundreds column. I need to move our 2 ones into our tens column, and then that leaves our ones column empty. So I need to put a placeholder in there to stop those other digits falling back into that ones column. So 12 times 10 is 120. Excellent. Can you have a go at working out what you think 13 times by 10 is? You can draw down the place value table and you can move the digits along and add your placeholder. Have you had a go? Excellent. If you need more time, keep the video paused, but let's go through it. Our digits in our number 13, when we times by 10, they're getting 10 times bigger. So I need to move my 110 into my hundreds column, and I need to move my 3 ones into my tens column, and then that leaves the ones column empty. The ones column is not allowed to be empty, so I need to put a 0 in there. So 13 times by 10 is 130. Excellent, well done. So I've now bobbed on some questions for you to have a go at. Pause the video and have a go. You might want to use a whiteboard or a piece of paper and a pencil. But what you can do is you can draw your own place value table by doing your hundreds, tens, and ones. And let's say we were doing 16 times by 10. I would put 16 in my place value grid, and then I would look at the digits and I say, well, that has to move here. And then my 6 has to move into my tens column. I can't leave my ones column empty. So 16 times 10 is 160. So that's how you can do it on your sheet of paper. When you've had a go at doing that for 14 times 10, 15 times 10, and 18 times 10, play the video again and we'll go through the answers. Okay, well done for having a go. So let's have a look at 14. So I'll draw it this time to show you how that should look for you on your whiteboards or pieces of paper. So we've got 14, that's got 110 and 4 ones. It's getting 10 times bigger, so my 110 is going to become 100. My 4 ones is going to become 4 tens. I can't leave my ones column empty, so I need to put a placeholder. So 14 times 10 is 140. Excellent. Let's do the same then for 15 times 10, where I've got 110, 5 ones. It's getting 10 times bigger. So my 110 becomes 100. My 5 ones becomes 5 tens. My ones column is empty, so I need a placeholder. So 15 times 10 is 150. And then 18 times by 10, well, that's got 110 and 8 ones. They're getting 10 times bigger, so my 110 becomes 100. My 8 ones becomes 8 tens. And I can't leave my ones column empty, so I have to put my placeholder, which is a 0. So 18 times by 10 is 180. Well done. Okay, what we're going to look at today in maths is some word problems for multiplication. So what we're going to do is we're going to read the word problem. We're going to work out how many groups there are. We're going to work out how many items there are in each group. Write that as a multiplication equation and then use our skip counting to be able to calculate it. Excellent. So 2 boxes. Each box has 5 cakes in it. So I've read it. There are how many groups? So there are 2 groups and there are 5 cakes in it. So remember, I could say that there are 2 groups of 5 by saying 2 groups of 5. Or I could say that I've got 5 2 times, whichever way round you want to write it. But either way, I'm doing 2 groups of 5 or 5 2 times. So I show my 2 groups and I count 5, 10. So that means there are 10 cakes all together. Let's have a look here then. I've got 3 bags of carrots. Each bag contains 10 carrots. How many carrots are there all together? So I read my word problem. There are how many groups? There are 3 groups. So I've got 3 groups of, how many are in each group? 10. I've got 3 groups of 10. Or I could say that I've got 10 3 times, if that's what is better for you to write. So then I need to write that as my multiplication equation and calculate my product by showing my 3 groups and then counting 10, 20, 30. So altogether, there are 30 carrots. So I would write that in here. Probably not on the side. I should have used the square and I would have written 3 times by 10 equals 30. Or I could have written 10 times by 3 equals 30 because it's the same. Okay, this time I don't have any pictorial representations here to help me, but I do have space to draw my own. So there are 4 children. Each child has 5 marbles. How many marbles are there all together? So I've read my word problem. How many groups? Well, there are 4 children. So I've got 4 groups. And inside each group, I've got 5 marbles. So I could, if I want to, draw my 5 marbles like this. Or I could just write the number 5 digit. It's up to you. So now I've worked out how many is inside each group. I need to represent that as an equation by saying 5 4 times, or 4 groups of 5. They will both get the same answer. Either way, I've got 4 groups and I'm counting 5, 10, 15, 20. So there are 20 marbles all together. Okay, this time I don't have anything pictorial at all to help me. So there are 9 children. Each child has 10 pence. How much money do they have all together? So I've read the word problem. I've identified that there are 9 children. So that means there are 9 groups. We've got 9 groups of. How many are inside each group? Well, each child has got 10p, so it's 9 groups of 10 equals. So now I've written it as an equation. So altogether, I've got my 9 groups and I count 10, 20, 30, 40, 50, 60, 70, 80, 90. Or remember, as always, we could have written it commutatively and said that I've got 10 9 times, and that would have given me the same answer. Okay, so there are 80 people at a party. You can seat 10 people at a table. How many tables do you need? So this time, this word problem is working out a missing factor, because what I do have is I know that there are 80 people at this party all together, and you can sit 10 people at one of the tables. So I know that there are so many numbers, so many groups, but I don't know how many groups yet. I've got a missing number of groups, but in each of my groups, there are 10 people. So how many groups of 10 will give me 80? Well, if I know that I'm using groups of 10 and I know that 10 is a factor, well, what I can do is I can count in my tens until I reach this number. So 10, 20, 30, 40, 50, 60, 70, 80. So how many groups did I need of 10 to reach 80? That's right, I needed 8. So these questions, I think these are maybe the pentagon sheet, okay? So remember, only do these if you're looking for that greater depth level of challenge. And then the final level of challenge that you'll come across in your worksheets is to write your own word problem. So remember, this word problem could represent 4 groups of 10 or 4 10 times. So you need to create a situation where there's groups. So you might say, there are so many children in a team. So I could say there are 4 teams and each team has 10 children. How many children are there all together? Or I could maybe talk about food. Food's a good one. Bags of sweets, maybe boxes of cakes. There are 10 boxes of cakes. There are 4 cakes in each box. How many cakes are there all together? I could talk about fruit, maybe, any kind of food is really good for multiplication. Groups of, teams, tables, anything where they're in a pack. So maybe pencils in a pack. You could say there are 10 packs of pencils. Each pack has 4 pencils inside. And it's up to you if you want to maybe draw a picture to represent that. So let's go with pencils, for example. It's going to be very difficult for me to draw, and I'm sure you'll do a much better job. But let's say I've got my 4 packs of pencils. And then in each pack, I've got 10 pencils. 5, 6, 7, 8, 9, 10. I'll just do a sideways one. There you go. So I've got 10 pencils in there. I need to put 10 pencils in here, 10 pencils in here, 10 pencils in here. And then now I've worked out what I'm going to write. I can write my word problem and say, you know, there are 4 boxes of pencils. There are 10 pencils in each pack. And then my question will always end with, how many pencils, oh, not pencils, pencils are there all together? Okay, so you can use this sentence frame if you like. There are so many boxes. There are so many items in each box. How many objects are there all together? Use this to write your own word problem. So yeah, it's time to have a go yourself now. The circle sheets are just like what we did at the beginning. 2 children, they've got 6 sweets each. It's there represented for you. So what you need to do is you need to work out 2 times 6, 2 groups of 6, or like we said, we've got 6 2 times, or we could say, because we know that that's commutative, we've got 6 2 times, 2 groups of 6, we can still use our 2 times tables. So we get our 6, 2, 4, 6, 8, 10, 12. The semicircle sheet is, it's not, sorry, so the semicircle sheet is just a box there for you to write your total in, but you do still have the representations to help you. And the triangle sheet, there are the number of groups, and you need to fill those with the number of objects that are in each group, and then write your answer somewhere. The square sheet has no visual representation for you. That's not to say that you can't do your own. You can absolutely draw your own to help you work out the answer if you want to, but remember we are skip counting in the number of whatever one of the factors is. The pentagon ones means that we have the total, but one of our factors is actually missing. And then the hexagon sheet after all that is for you to write your own word problem. So remember, have a go at 2 of the sheets that are at an appropriate level of challenge for you. But once again, well done everybody. You're all doing an amazing job at home. Remember to keep joining the online phonics lessons. It's really nice to see you all, and keep on with your maths and English and curriculum lessons through the YouTube videos as well. Bye everybody.